G'day, welcome to another one of these videos. In today's video, we're going to be testing something that I'm kind of a little bit excited to test, and that is, what is it? It's that um, word length is going to have a number of correlations in this data set with these psycholinguistic domains. We're testing 19 psycholinguistic domains. And I think we're going to find some kind of interesting correlations. Essentially, my theory is that strong emotions are going to have a positive correlation with length, regardless as to whether those strong emotions are longer. I'm sorry, regardless as to whether those emotions are positive or negative. I think that um, any extreme emotional feeling is going to have a positive correlation with length, whether it's positive or negative. Um, yeah, so we'll go through these, we'll test them, we'll run some other tests. We should probably talk about the data a little bit. Let me open it up in Excel. I like using Excel because you can very clearly find your mistakes in Excel and it gives you a good overview of the data without having to call it up. I think that Excel is pretty largely overlooked by a lot of people in machine learning, but I use it all the time. I think it's a very useful program. All right, so this is our NRC data. Here we see that we have binary responses to anger, anticipation, disgust, fear, joy, negative, positive, sadness, surprise, and trust. Just out of interest's sake, it's going to be, let's open this up here. I want to know what percentage of these are going to be null values because that's going to have a big effect on our effect size. So this is 13,000, so that's about 10%. And we'll just take a look at some of these other ones. Okay, less than 10%, less than 10%, a little bit over 10%. All right, we get the idea. So what we're looking at a data set with about 90% null values, which is pretty extreme. Okay, let's not save this. Oh, wait, I should talk about this. Here we have a length variable, which I have included from the previous video. The length variable is a very simple code. It is just the sum of all of our independent variables. So all of our phonemes, drag across, and we calculate by getting the sum. And that's for all of them. Normally when I do this, I check, I find a nice big number, and then I go through and I have a look. Abandonment, abandon. Is that American English? Sorry again if that's your native language. It's just a bit strange to me to see some of these phonemes in these positions. Abandonment, we have 11. Cool. All right, so cool. That's the length variable, and that's the variable that we're going to be using as our independent variable in these regression models. All right, so let's call up that data with the length variable and make sure it's in there. So here it is, capital L length, capital L length. All right. So normally what I'll do is whenever I do any kind of data manipulation is I'll run a checksum to make sure that there hasn't been some kind of issue, but I don't know. I haven't done that here. I'll do it probably like if this is going to present something worth publishing, right? Like if this is going to present something that's worth putting into a paper somewhere, then I'll certainly do the due diligence. But right now I am just exploring for my own personal curiosity, really. So central thesis, what is our hypothesis? More emotional words, regardless as to whether those words are positive or negative, will have a positive correlation with word length. So arousal will have a positive correlation with word length. We can take a look at the Glasgow norms. We can take a look at the Glasgow norms, and we can actually have a look at how they ask these questions. So arousal, a word is arousing if it makes you feel stimulated, excited, frenzied, jittery, or wide awake. So high score is arousal. Valence, a word is positive if it represents something considered good, and negative if it's something bad. Now, in my hypothesis, which is that neutral words will have a negative correlation with length, whereas positive and negative words will have a positive correlation with length. There should be no correlation with valence, right? Unless one of those positive correlations is stronger than the other. Dominance, a word makes you feel dominant. Okay, so a high score is makes you feel like you're in power, and a low score makes you feel like you're not in power. Concreteness versus abstractness. So a high score is something that's more tangible. Imaginability, something you can imagine, easy to imagine or picture. Familiarity, high score means something familiar to you. Age of acquisition, I'm imagining that these will probably have the same positive correlation due to Zipf's law, which we were talking about in the last video, which is the stochastic relationship between word frequency and word size, which is a negative correlation. However, here, these are kind of going in opposite directions, right? Something that's familiar to you has a high score, and we're expecting a low, like a shorter word to be more familiar. So there should be a negative correlation for familiarity and a positive correlation for age of acquisition. Semantic size, we know that big words represent big things. So expecting a positive correlation. Gender association, all right, so men are typically larger than women, but in a number of the world's languages, we find that femininity is expressed in longer words. So I'm not sure with this one. Something interesting about the Glasgow norms is that some of them are based on a 7-point Likert scale. I don't know if you would call age of acquisition a Likert scale, because these numbers are representing ages. Like, it's just a weird way of kind of representing the age of acquisition. But for everything else, these are all Likert scales, but arousal, valence, and dominance are based on a 9-point scale. All right, let's get into it. So arousal, something arousing, that is an outlier emotion, right? Like, it's not, you wouldn't call that a neutral emotion. So we're expecting longer word. And yes, positive correlation. Because this is the first one of these that we've run, it's certainly significant, but we don't know how strong that correlation is. So we'll go and have a look. Valence, I think no correlation, right? Like, that's my guess. No correlation. So a slight, like, it's significant, like it's just significant, but it's significant, but there is a positive correlation. Wait, is positive good or bad? Positive or negative? What is positive? Indicate scale very negative, very positive, with midpoint remaining neutral. I'm assuming, all right, what's frustrating here is it doesn't tell you if a high score is positive or if a high score is negative, but for everything else, the first one mentioned is the high score. It's the high score, so right. Gender association, masculine first, feminine second. We know that high score is masculine. Same with big, small. So I'm just going to assume that, yeah, a high score is, where were we? A positive. So we're seeing a slight correlation between positivity and length, but yeah, I think that negativity will also have a positive correlation, which we'll test in a moment. Dominance, something that makes you feel in control. Maybe that would be a shorter word, just as a guess. No correlation. Concreteness, something that's concrete versus something that's more abstract, I guess, is a shorter word, so negative correlation. Yes, pretty strong comparatively. Is that the strongest we've found so far? Maybe I'm not going to go back and check, but yeah, that's quite a strong correlation. So something that's concrete has a shorter word than something that is more abstract. Imaginability versus something you can't imagine. Negative correlation. Negative correlation. Okay. So something that is more abstract or something that is less imaginable. You can't picture it. You can't picture it using your imagination. You can't think up the picture of it. Then that will be represented with a longer word. So those two together are these are kind of interesting, right? Okay, cool. All right, familiarity. Same as age of acquisition, except familiarity runs the other way. So we expect a negative correlation, and there is one, but it's not super strong. Age of acquisition, I think, will be really strong, but a positive correlation because we kind of tested this in the last video. And yes, strong positive correlation. That is the strongest effect size that we've seen so far. But it might be beaten here by size because we know that larger words represent larger entities. And no, it doesn't. Okay, so the size does have a positive correlation with word length, but it's not as strong as age of acquisition. Gender, we guessed no correlation, but now I'm thinking maybe feminine. So that would be a negative correlation. Not significant. Okay. Moving on to the NRC. I've set these up as so if we take a look at the Glasgow norms, what I was running those off was the average of the Likert scale and the length variable. With the NRC data, we're running those off the binary responses here. For the anger model, I've provided the GLM with the binomial family and the simple linear regression model, just because I was kind of interested to see how much of a difference these are going to report. Now, obviously, if you are reporting this in an article, you're going to want to report the correct effect measure. But I've got a funny feeling that there won't be too much difference. Anyway, anger is a strong emotion, so I'm going to expect a positive correlation. Anticipation is a strong emotion, positive correlation. Disgust, the same. Fear, the same. Joy, the same. Negative and positive. Now, these two models here, this was the reason why I was kind of excited to come in and make this video, because I'm expecting that both of these will have a positive correlation with word length. Sadness, the same. Surprise, the same. Trust. Now, trust is interesting. When we think about somebody who's trustworthy, like somebody who speaks plainly, using plain, simple English, short words, is that more trustworthy than somebody who speaks maybe more scientifically with longer, more scientific sounding words? I think that it's probably like based on the individual. And upon that hypothesis, I think that there won't be a correlation. I think that there'll be no significant correlation. Let's test it. All right, this is the GLM for anger. Positive correlation, only just significant, and it doesn't look particularly strong. I did want to run the LM just to see mathematically if there's much difference here. So we're looking at 2.0, 0.035, 2.0, 0.035. Okay, so not a whole heap of difference in these two models, but again, report on the right statistic if you're going to be publishing your data. Anticipation, positive correlation. Trending towards positive, not quite there, but yes, there is a positive correlation there. Disgust. I said positive correlation. I'll stick with it. Okay, not significant. Fear. Not significant. Joy was going to be positive correlation. Not significant. All right, negative and positive. These are the big ones that I really want to test. Okay, negative. We definitely have a... Okay, so there is a positive correlation for negative emotion, But remember, we ran the was it valence? Yeah, we ran the valence one, and the valence had a weak positive correlation. So here we've just run the negative one, and that's telling us that there is a positive correlation. Now, if the previous model was accurate, if it's actually reporting on something observable in the real world, then that means that the positive model will return a positive correlation that has an effect size greater than Z equals 3.5. There's my hypothesis. Let's test it. Wonderful. Okay, so positive words are longer apparently than negative words, but both of them have a positive correlation with length. Why does that make me happy? That makes me happy. I don't know why that makes me so happy. Interesting. All right, sadness. Expect a positive correlation, and we see it. Not super significant, not super strong, but it's definitely there. Surprise, positive correlation. Not significant. And trust. Trust is interesting. I'm not going to make a prediction for trust based on what I said earlier. Somebody who speaks plainly, is that person more trustworthy than somebody who speaks with longer words? Let's just test it and find out. Oh, okay. So something that's more trustworthy has a positive correlation. Words that make you feel trust or have a trust connotation to them has a positive correlation with word length. Okay, so perhaps like more scientific, academically sounding words, academically sounding words, more academic sounding words. These seems this is possibly the reason why we're finding a reasonably strong positive correlation here. All right. That was everything I had planned for this video. Um, I was thinking on the bus this morning. I was riding the bus to work and I was thinking about Twitter. In machine learning, we have these data sets which we call Hello World data sets. We call them Hello World data sets because Hello World is the first thing that people learn to code. Like you learn how to print Hello World in whatever language you're learning. Hello World data sets are the kinds of data sets that you learn to construct machine learning algorithms on. So I think the very first random forest I ever built was using the Iris data set or the MT-Cars data set. There are other data sets that fall into that category. I can't remember the names of them. There's a house price data set, which is a lot of fun to play with. A lot of fun if you're me. You might not find it so much fun, but it's yeah. There's lots of interesting. Anyway, shut up. Twitter is typically used as kind of a hello world data set for what we're going to be doing in these videos, which is kind of looking at automatic emotion recognition. Because there are some data sets that have been annotated. They've been ascribed scores according to emotion recognition. I can't think of them off the top of my head, but I think I'm going to go and have a look for them because Twitter is what 147 characters, right? And if we take a look at our Glasgow norm data set, these are our dependent variables that we're going to be constructing the models on. And they're made up of mostly null values, right? Somewhere between 80 and 85%. I haven't calculated for this data set, but based on like my previous experience, it's somewhere between 80 and 85% null values. Now, if you were to take a tweet, then this data set would suddenly become a lot more richer. There'd be a lot fewer null values. And in decision tree based machine learning algorithms, which is what we're going to be constructing in these videos, lots of null values can cause overfitting. We'll probably talk about that later in a different video. But yeah, so I might go looking for that Twitter data and I might make a video about it if I find something that's worth analyzing. Anyway, I will catch you later. I hope you enjoyed this. I'll see you in the next one of these.